converting a number system. So the conversion between number systems depends on the relative value of the transition number, quote, 10. The number 111, not its actual value, can be written in the same way for base 10, 4, 2, or any base number system in general, just because the number or the digit 1 is included in all of these base number systems. So 10 is included from 0 to 9, and this one's included from 0 to 3 for the 4. And for binary, 1 is the only digit, just 1, 0 to 1, or if you include 0, so 0 to 1, and so on. So we could write these all, and it's all going to look in the same format. So 111 equals to 100 plus 10 plus 1, which equals to 10 to the power of 2 plus 10 to the power of 1 plus 10 to the power of 0, where note 10 to the power of 0 is equal to 1, which is equal to just any number to the power of 0 by definition, and but 0 to the power of 0 gets a little tricky, but we won't be dealing with that in this video. Anyways, let's go further. So the conversion from most bases to base 10 is relatively straightforward because most calculators, including the built-in one-node calculator, which I'm using for these video notes, is in base 10 by default. So that means if we have this 1 plus 1, this one's built in, if I press space, it automatically calculates the 2. So it's automatically calculated. But if I was trying to calculate in base 2 right here, so 1 plus 1 equals 2, we'll have to type this manually because it's base 2. There's no number 2. There's no digit 2. It's only 0 and 1. But I have to manually calculate that, or manually type that in. So that's 1 plus 1 is 10 in base 2. But notice the conversion right here. 10 base 2 is equal to 2 base 10, because these are just 1 plus 1. 1 plus 1, these are the same value. So the exact value is of base 2, the number 10 or 10 is equal to 2 in base 10. So thus, to convert the number 111 from base 2 to base 10, we can simply replace the transition number, quote, 10 with the relative value of 2, and then simply add up the terms using the base 10 calculator. So if you have 111 in base 2, this equals to, well, 10 to the power of 2 plus 10 to the power of 1 plus 10 to the power of 0, as I went over earlier. And now we just replace the 10 by 2, so we have 10 to the power of 2 plus 10 to the power of 1 plus 10 to the power of 0. This is all base 10 equivalent, and we just calculate these up. So 2 to the power of 2 is just 4, and then 2 to the power of 1 is 2, and then 2 to the power of 0 is 1. So what we have is 4 plus 2 plus 1 is just 7. And here's automatic calculator, 7. All right? So this means that 111 in base 2 is equal to 7 in base 10. We can see that this is true by counting in base 10 the numbers in base 2 up to and including 111. So we have 1 and then 10, 1, then 10, that's 2 numbers. Then the next one after that is 11, and then we get, so we maxed out these 2 digits, we needed another 0, so another 2 zeros. So 100, then 101, 110, and all of a sudden we get this 111 number. And these are 5 numbers. So there's 2 numbers on top. There's 5 numbers. So 2 plus 5 is 7 numbers, which is base 10 count. So 111 is equal to 7 numbers in base 10. So that's the conversion. So likewise for base 4, the transition number now has the transition number, quote, 10 has a value of 4 relative to base 10. So thus, to convert this to base 10, we'll do 111 base 4 is equal to 4 to the power of 2 plus 4 to the power of 1 plus 4 to the power of 0. Now this is going to be written, now this is base 10. So this equals to 16 plus 4 plus 1. 4 to the power of 2 is 16. This is 4 times 4, and 4 to the power of 1 is 4, plus 1, and you add these all up, you get 21. Here's the automatic calculator, 21. So that means 111 base 4 is equal to 21 base 10, and we can count these up as well. So 1, 2, 3, and then 10, so that's 4 numbers. And then we go 1, 1, 1, 2, 1, 3, then we go to the 20, or 2, 0, we have to jump there. So 2, 1, 2, 3, 2, yes, 2, 1, 2, 2, 2, 3, the next one's going to be 3, 0. Then we go 3, 1, 3, 2, 3, 3, and then we add another 0, go to the 100, so 1, 0, 0. These are 12 numbers. You can see this is going to be, this is going to be 4 plus 4 plus 4. Yeah, so 12 numbers. The first one's 4 numbers, and then 12 numbers, and then the next one after this is 1, 0, 1, and then 1, 0, 2, 1, 0, 3, and then 1, 0, 1, 1, 0, and then after that is 1, 1. 1, that's 5 numbers. So we'll have 4 plus 12 plus 5, 4 plus 12 plus 5 is equal to 21 numbers, or base 10 count. So that's how you can, double check. That's exactly the same thing. So now converting from larger base numbers to smaller base number systems is similar, Yeah, but for those cases, it requires accounting for the extra digits not present in the lower bases. So yeah, so for example, base 10 to base 4, you're gonna have the deal with the number 9, the number 5, number 6, etc., even the number 4. So to do that, we'll do right here. So 10 and base 10 is equal to, well, 4 plus 4 plus 2. Yeah, so I had to actually write that out there, and notice this 4 and base, we could just add these up. So this is going to be 2 times 4, is just 4 plus 4, plus 2. And now this 4 and base 4, because we're converting it, in this case, to base 4, this is going to be 2 times 4 to the power of 1 plus 2 to the power, 2 times 4 to the power of 0. Just include that 1 there, that's invisible, because 1 times 2 is just still 2. So now we'll change this into 10 now. So this is written in this form, but this 4 doesn't exist in, this 4 is equivalent to 10 in base 4. So we go 2 times 10 to the power of 1 plus 2 times 10 to the power of 0 and base 4. In other words, we get now 2 times 10, because 10 to the power of 1 is just 10. So 2 times 10 is 20, plus 2 times this is just 1. So 2 plus 20 plus 2, base 4. So we have 22. And we can see that this is the right way as well by, again, counting up. So if we go look at base 4, so we go 1, 2, 3, and then 10. That's going to be 4 numbers. And then 1, 1, 1, 2, 1, 3, then go to 20, and then 21, 22. These are 6 numbers. So in other words, we have 4 plus 6, 10 numbers. So 4 plus 6 is 10 numbers, base 10 count, so they're equivalent. Similarly, converting from base 10 to base 2 is visualized as follows. Again, just for completeness, we have 10, base 10. Yeah, from base 10 to base 2, this is visualized as follows. So 10 base 10 is equal to, I'll put this as 8 plus 2. And the reason for that is because 8 is just 2 to the power of 3. So we just wrote it as a power. And then this 2 is just 2 to the power of 1, and there's no 2 to the power of 0. So we just have this now. So then convert this into base 10, so write that as a 10. So 10 to the power of 3 plus 10 to the power of 1, because this relative value 2 goes to 10. And now we have this, and this just equals to, well, 10 to the power of 3 is equal to 1,000. So yes, 10 to the power of 3. 10 to the power of 2 is 100, 10 to the power of 1 is 10. So we have 1,000 plus 10 to the power of 1 is just 10. So we have 1,000 plus 10 is just 1, 0, 1, 0, base 10, and base 2. And we can confirm this by, well, writing this out or expanding it or counting it. So we have 1, 1, 10, 1, 1, then 1, 0, 0, 1, 0, 1, and then we have 1, 1, jumps there, 1, 1, 1, and then 1,000 right there. That's 6 numbers. So we have this 2 numbers, 6 numbers, and then we've got to keep going to this number. So we go 1, 0, 1, 1, 0, 1, 0, 1, 0. So that's 2 numbers. So we have 2 plus 6 plus 2. That's 6 plus 4. That's 10 numbers, base 10. That's pretty amazing stuff. And lastly, we can convert from base 4 to base 2 as follows. So we could write this 10 base 4. This equals to, well, 2 plus 2. Because again, this is base 4. So that's the equivalent value of 4 in base 10, or 2 plus 2 in base 2. That's just 2. This is 2 to the power of 2. This just equals to 4. Or 2 to the power of 2, or 2 times 2, same thing. And this equals to, replace that with a 10. So 10 to the power of 2, base 2. So in other words, 10 to the power of 2 is 100. So 100. And we can see that. So we go 1, 1, 0, 1, 1, and then we go 100. 4 numbers, base 10 count. Just to show that they're equivalent. So we have 4 numbers, the same value as this 2 plus 2. And this is the number 10 in base 10. And base 4. And which is as expected. Again, 4 numbers base 10 count, just because used to that counting method. So now, since most calculators are in base 10 by default, and my brain and most people's brains, it can be tedious to convert from and to non-base 10 systems. Now, nonetheless, I have developed a simple base 10 to base X conversion calculator on Microsoft Excel, which calculates as per the following example. Just illustrate how it does it here. So if we have base 10 to base 8, or Octal, this is also called Octal, and there is a built-in function in Excel to convert to octal or binary and so on. So we have base 10 to, so if we have a base 10 number 11, we want to convert it to base 8. What we'll do is, the procedure is divide 11 by 8. So if 11 divided by 8 equals to 1.375, then separate this out into a whole number plus the remainder. So 1 plus 0.375. Now, if we have 0.375 times 8, that equals to 3, so it's it goes evenly into 8. So that means if we just move this 8 over here, so 3 over 8 is equal to 0.375. So what we can do is we can write this as 11 over 8 equals 2, and we're going to write this number 1 as 1 divided by 8 times 8. So we're not changing anything here. We just have divided by 8 times 8, that's 1, it goes over there. And then there's going to be plus 3 over 8. So we'll show you why we're doing that in a bit. So next step is 1 divided by 8. Divide this out. We're going to have 1 divided by 8 equals to 0.125. And then write this as a remainder plus, the whole number plus remainder. And the whole number is 0 in this case, plus 0.125. And 0.125 times 8 gets an even number, or a whole number 1. So that means we just divide this 8 over here. 1 over 8 equals to 0.125. So that means 1 over 8 equals to 0 plus 1 over 8. And the 0 is redundant, but I'm just going to keep it there so that we know when to stop. So 0 over 8 equals 0. Just stop here. And now, let's bold this one. So the next step is we can write this all together. So we'll have 11 over 8, which equals to this over here. 11 over 8 equals to 1 divided by 8 times 8 plus 3 over 8. And then we're going to add this inside this 1 over 8. We're going to put this inside here, and then we're going to get this entire formula there. And then multiply this 8 out, expand this whole thing out. So we're going to have a 0 times 8 plus this is going to be 1 over 8. So those cancels. We're just going to have a 0 times 8 plus 1 plus 3 over 8. So that is what we have thus far. But this is 11 over 8. So now we'll multiply everything by 8 to get rid of this 11. So 11 equals to 8 times 11 over 8. So then when we multiply this all out, what ends up happening is, well, this 0, we're going to have 0 times 8 is going to be, 8 squared. So 8 times 8. And then this 1, we're going to have times it by 8, which is 8 to the power of 1. And then we're going to have this 3 there. 3 over 8 times 8, that just cancels into 1, or 8 to the power of 0. That's just equal to 1. And then we can convert this into base 8. So 11 base 10 is equal to 0. Write this as 10, because remember it's 8. This is base 8, so that's in base 8 will be just 1, 0. So 0 times 1, 0 times 10 squared plus 1 times 10 to the power of 1 plus 3 times 10 to the power of 0. In other words, those are the transition numbers, and this is base 8. So we can just add up these terms. This is going to be 11 base 10 is equal to 0, 1, 1, 3 base 8, and the 0 is just redundant. It just tells us when to stop our algorithm. So we're going to have is equal to 113. Or just 13 is the number. And we can see that here. Here's the Excel sheet. There's a link to it. And here it's in the worksheet base 10 conversion. So yes, keep hold of this one. I'm going to use this Excel sheet in this video throughout, and likely the future videos. So we have base 10 number. Here's the exact procedure. So we have a number 11 like here, and there's the base. We want to convert this into base 8, and this is base 10 there. And it's number 11 base 10. And also there's an octal base 8 conversion within Excel. It shows automatically goes to 13. There's a check. It just subtracts this 13 from this to see if it's correct, and the 0 is checked. There's also binary 1 here. Just ignore this check because it depends on the binary. Binary is base 2. Octal is base 8. Like an octopus, I believe that's 8. Yeah, octopus, I believe is 8 tentacles and so on. So anyways, so if we divide this out, so we start out by this number base 10. 11. So if we have 11 divided by 8, we get this 1.375. It's the starting one. It's the only part that's not part of this formula where I divide this into here. So anyways, so we'll have round down divided by base, but except this orange one, which is this. So this divided by here, by 8, we get to this point right there. And then this equals to, we'll round down, it's going to be 1 plus 0.375. But then if you multiply that, that's just 3. That's our 3 over 8. Yes, that's our 3 over 8, this part right here. This is times by 8. And then the next step is going to be 1 divided by 8, which is divided by 8 right there, 0.125. It equals to 0 plus 0.125. So we've finished there, and that just equals to 1 times by 8 equals to 1, like that. And then you just add up the digits. It's going to be 0, 1, 3, but in this case, 0 is ignored. So 1, 3. And decimal or base 10 sum, that's going to be 4, 1 plus 3 is 4. Anyways, note that decimal refers to base 10.